day 7 of competitive programming. So let's open the setup. Timer 60 minutes and opening CodeChef. Okay, yesterday we have solved 2 sums. Today we'll be trying to solve 2 more in 1 hour time, which are based on time complexity. So first we'll solve them normally, then if we face time complexity, then we'll be trying to reduce the time complexity. Autumn kmx.cpp. You are given an array A containing n integers. Find if it is possible to choose exactly m elements from the array such that the max of the chosen elements is exactly k. Recall that the max of an array is the smallest non-negative integer that does not belong to the array. For example, the max of 2 to 1 is 0 because 0 does not belong to the array. The smallest non-negative integer. The max of 3101 is 2 because 0 and 1 belongs to the array but 2 does not. Max of the chosen element is exactly k. Find if it is possible to choose exactly m elements. Okay, they are giving an array, so let's use our array snippet. Now the first line contains we are reading the first line of each test case contains n, m, k. So let's take n, m, k, and then I think the length of the array, the number of elements to be chosen, and the required max respectively. K is the required max, m is the elements. For each test case, print as if it is possible to choose m elements from the array A so that the max of the chosen element is exactly k and no otherwise. You may print each character. Okay, we need to print yes or no. We got 542, and if 2 is present, okay, yes. Well, first we need to check whether 2 is present or not. We'll go for we'll sort that and then we'll go for binary search. Search a comma n plus 1. And we cannot unsort it, right? So let's just say, let's take sort array, and we'll also read the same elements. We'll just copy a of s of I equal to a of I. Now we'll sort this array. Sort s n plus 1. We can use our merge sort, which is written by us, but we'll use just the sort function. Now after sorting, we need to find whether n is present or not, so we'll use binary sorting here. So let's say void binary sort. Okay, we need to take the array into key. Let's take int l, lowest element and the highest element. Let's calculate mid is equals to l plus h by 2. And if key is greater than mid, l is equals to mid plus 1. We might not have one more line here, we'll just do this. Else if key is less than mid, h is equals to mid minus 1, and we need to call the binary element, right? Binary search it is actually. Binary search will pass the same array, will pass the same key, and will pass the same l and h. Okay, actually it is common for both of the things, right? So let's just have it in this way. Now else it will be equal return else if key is equal to mid return 1. We can return with bools also, but let's use this. We'll just put this inside this. Same here. If none of this happens, we'll return 0. If this thing fails, then we'll have 0. If that element is not found, we'll return 0. Okay. If binary search of yes comma key is a comma key is k comma L0 and n. If it is true, if it is not true, okay, we got S. If we found that element, we need to have the key of the element also, right? One, it is no, because 2 is not present in it. The chosen elements are test case 2 which is equal to 3. Okay, for test case 2, 4 and 5 there is no way to choose elements to obtain the required mix. In which cases we'll be printing no. If all the elements are less than, if it is not found, we'll say there is no possible way, right? If it is 0, then we'll say no. Okay, if element is not found, then there is okay, we cannot do in those ways. We cannot go for the lesser value or higher value. How can we do this? If we sort it, we'll get 1 0 0 1 for first test case, which is 0 1 3 0 3. If it's sorted, we'll get 0 0 1 3 3. And if we have 0 1, we don't have 2, so we'll just say yes. In next test case, we have 0 and 1. We'll sort the array, will come from the, okay, we'll search for 2. If 2 is not there, we are saying yes, but if 2 is present, if 2 is present, what should we do? We need to check. Let's just return mid value. But if the key element is in first position, we'll get 0. Then let's just always return mid plus 1 value. Okay, this will be a of mid less than a of mid. That's a mistake there, I forgot it. A of mid. So it never returns 0 value. In here, it always returns 0 plus 1. And when we are obtaining it, give the binary search mid value, right? Let's just say, take it that int x is equals to, let's take all of these and paste it here. Now we got our binary search. Okay, what should we do right now? Let's spend half an hour on this time in this question, and then if you're not able to solve, then we'll go for the answer. Can we take just a map and have all the frequency of elements? This mix can be in any order, but or it should be in sub like 204, or it could also be 243. For test case number 6, this is 1, this is 2, this is 3, this is 4, 5, 6, last test case. He took 0, 1, 0, 0, 3. He just avoided 2. For test case number 3, he's saying 0, 1, 2. How can you take 0, 1, 2? This is 1, this is 2, this is 3. Well, okay, this is 0, 1, 2, this is 3. And the key is 3, so we got 3, 2, and 2. Okay, in 0, 1 we can get 2, right, for second question. What is 1? 1 is the elements from the array. M elements from the array. I'm not able to think for a solution for this question. Okay, he will give the size of the array we need to select. He will give the array elements, and he will also give the size of the array. I'm thinking like somehow the size of the array minus index of this. Number will somehow remove the I'm thinking we'll give the answer. We are it seems too much of complicated. I'm not able to wrap my head around it. I'm thinking like we'll maintain a map where each element is repeating how many times, and then we'll take the for loop, and It seems too much of complicated. I'm not able to understand or wrap my head around it. I guess for today, I will do it tomorrow. I'll solve this question tomorrow. For today, let's go back to the modules. We'll just go to practice and we'll start doing array sums from 1400 to 1500 level. Name reduction is for our first sum. Remove element is our second sum. Okay, name reduction, let's just say autumn. I'll remove kmx because we haven't solved anything in there. Next we'll go to autumn. In autumn, what is the full name? 1.cpp. In an attempt to reduce the growing population, Archer was asked to come up with a plan. Archer, being as intelligent as he is, came up with the following plan. are born to parents with names A and B, and you consider C to be the concatenation of all the numbers. Where is concatenation operator plus is concatenation, and C should be a substring of one of the permutations and combinations. And you are given the task to verify whether the names parents proposed to given the children are in fact permissible by Archer or not. Okay, this okay, let's read our input first. What are these dollar signs? The first line of each test case contains an integer, the number of test cases. Each test case follows a two-space operator in integers A and B, denoting the name of the parents. The next line contains a single integer n. The number of children A and B are planning to have. Following these are n lines. Okay, what is this? This th line containing ith line. Okay, this the ith line containing ci, the proposed name for the ith child. For each test case, output a single line containing yes if the names are children, otherwise print no. One to parents with names A and B. So C has the concatenation for all the names of the children, that is C is equals to C1 plus C. Then C should be a substring of one of the permutations of A and B. Okay. C should be, we have Tom and Marvel, Riddle. T test cases follows. Each test case will contain a line containing two space operator and say okay, we have A and B, denote the number of names of the parents. So contains a single A and denoting the number of children A and B are planning to have. Following this, there are n lines, the line containing the proposed name of the children. Output should be 5 is the output a single line containing yes if the names are permissible by Archer's plan and no by Archer's plan. Okay, they are giving the Number of test cases, name of two players, and then they gave 2. 2 is a number. Come on, it's 2. It's just a 14 or 4 rated question. I should be able to solve this. Okay, here, what are we doing? I'm not getting any idea before even for this question also. Let's go for remove elements. A constant k using which you can perform the following operations on a. Choose the 2 distinct indexes I and j such that, and remove either a of I or a of j from a. It's possible to obtain an array consisting of only one element using several possible 0 such operations. Okay, input format, choose and 1 j equal to 4 and remove 5 since the array becomes 1 4 3, and the chosen test case I equal to j equal to 3, a of I equal to 4. Okay, the first array is, okay, first let's write our let's remove this things. Let's just say autumn remblam.cpp remove element.cpp. We are reading an array for test cases, 2 separated integers n comma k, c n n and k. Okay, now the output should be, yes, if it is possible after an array containing only one element, use the given operation, otherwise print no. You may print each character on string in uppercase or lowercase. Okay, what is the given? You are given a constant k using which you can perform the following operation on a. Choose 2 distinct indices I and j such that a of I plus a of j is less than or equal to k, and remove either a of I or a of j from a. Okay, we need to choose 2 elements. We'll solve the array. The length of the array is already 1. Okay, there is no way to delete an element from the given array. 3 3 or 2 2 2. 2 plus 2 is greater than 4. 2 plus 2 is greater than 4. 1 4 3 5. 5 plus 3 is greater than 8. So when we remove an element, we will remove 5. And 4 plus 3 is 7. For each test case, but if it's an array consists of only one. Is it possible to obtain an array consisting of only one element using several? Array should have only one element. Yeah, 2 plus 2 is 4. We can remove, which is greater than k. If it is lesser than k, we need to remove one element. So let's just simply sort the array. We'll take the maximum value and we'll take the least value. Distinct indices A, I, and J says that is it possible to obtain? Okay, we need to obtain array of only one element, right? So we'll sort it. We'll get the maximum element, we'll get the least maximum element, and we'll add them. If it is greater than, we'll just remove the starting number to 0. We'll take the second number, and then third number, and then fourth number. You cannot do that, but the time complexity is only the order of n. I understood this question pretty well when compared to the previous ones. This one seems more to the point and also logical. Is it easy to understand? I'm checking. Okay, we'll just write yes or no's. We are having our nk and a values. If n equal to 1, we'll just reduce the n value when it is equal to 1. When sum of two numbers is greater than k, then I will print a yes and a new line character. Uppercase of letters, for example, is of the string in uppercase or lowercase will be treated as identical. So for if we need to print and we need to start from the start, right? Don't continue, because if you continue, then I have no idea what to do here. We need to find the minimum and maximum number. If the sum of both of them is less than k, then somehow we can reach it. If it is not less than k, then we cannot reach it. So we'll just say no. That's the logic I'm thinking. So min is equals to, for int I equal to 0, I less than and I plus plus, we need to declare min equal to 0, max equal to 0. Min should be some number a of 0. Let's say first number is the middle. Even for this, let's just say that, and we'll say min equal to, if any number is greater than a of minimum, lesser than a of minimum, then minimum a of minimum, then we'll say it is the minimum. If it is true, a of I. If it is false, then we'll have only minimum itself. Okay, same for the max. If any number is greater than lesser than max, we'll just say the max will be max. If it is true, if it is false, then max will be a of I. Okay, that's how we are calculating the min and max. If max plus min is less than and equal to k, then cout I'm saying is yes, else cout I'm saying is no. I think that's the code. Okay, we have attached something. What did we attach the error with? Continuous statement not within a loop. Okay, if 1 equal to 1, n equal to 1, okay, it's not in. Okay, we need not continue. We need to call the solve function. No, we need not call it. We'll just say yes. And let's just say return. We'll return from here. We'll go for the next test case. Okay. Next, what are our errors? Was not declared in the scope. A is not declared in the scope. Int min equal to max equal to. Yeah, max is not a type, it's just a variable. Okay, this is comma. We still got few errors. Actually, we will try to solve 2 errors. So on 16th line, after if statement, okay, this thing, then after that if statement. Okay, everything on 6th line. Okay, that if is in which group? For is just to read. Then we have our if. If will be in this block itself. Then int sum is equals to. Okay, we'll take the minimum and maximum numbers. And we'll add both of them. If the value is less than k, then we'll print s, or else we'll print no. Okay, we got few errors. 23rd line. Okay, it's a function. Should we have semicolon there? And then let's just compile it for once. Let's just clear RMLM. Okay, just say out. Okay, we need to write this first. Then autumn dot shader dot. Let's you. Why did you open it? Okay, my bad. Let's just run it. Slash shader dot. We need to give our inputs, right? First, the test cases. What are our test cases? 9, 1 or 3. Okay, why did I type 9? I have no idea. So let's just say copy this thing and paste it here. Yes, no, yes. Okay, I'm getting proper answer for small values. Let's check what we'll get. Whether we'll get TLE or. So actually I was trying to. I didn't try to reduce its time complexity. Okay, yesterday. Okay, it is recording. It is as after 12. So okay, wow. Finally, we have done one correct answer after changing the questions. If we solve this question, we'll just stop doing it irrespective of the time. So let's just clear autumn unicourse.cpp and we'll remove this file. There are n courses in a university being offered. These courses are numbered from 1 to n in the increasing order of the difficulty. For each course you can have some course as prerequisite. The prerequisite course for a course should be of lower difficulty than it. You're given an array of size n where AI denotes that there should be at least AI prerequisite courses for ith course. Okay, it does make sense. The university wants to estimate the efficiency of the allocation of prerequisite of courses by maximizing the number of courses that are not prerequisite for any other course. Find out what's the maximum such number of courses possible. It is guaranteed that phi is less than I, thus making sure that it is possible to allocate the prerequisites for each of the course. Okay, let's take our test cases. Let's read our n, and then n space separate integers doing array m. Okay, we are for each test case output a single line containing an integer corresponding to the maximum number of possible courses which are not prerequisite for any other course. 0 1 1. Okay, for this case both the courses 2 and 3 can have course 1 as a prerequisite. In this case course 2 and course 3 are not prerequisites for any course, so we have two such courses. Okay, it's just a map function, right? You'll just take map int of int, then we'll just say of I of, okay, it's just a map, right? Let's just take a frequency. You need not read this also. Int x cnx and fric of x plus plus will be increasing in this way, and now int count equal to 0. Okay, it's just both the courses 2 and 3 for other possibilities could be following. Course 2 has course 1 as a prerequisite and course 3 has course 2 as a prerequisite. Thus only course 3 is the only course that is not the prerequisite of any other courses. Thus answer is 2. Other probability. What about this explanation? I just thought he's just giving the sum of these two. So here we have our prerequisite. How do you solve this? What is actually, I'm not getting the logic at all here. I mean, not the question at all. Yes, let's read the question one more time. There are n courses in a university being offered. Thus, courses are numbered from 1 to n in the increasing order of the difficulty. For each course, you can have some courses as prerequisites. The prerequisite courses for a course should be of lower difficulty than it. You are given an array A of size n, where AI denotes that there should be at least A of I prerequisite courses for ith course. Okay, for first course there should be one prerequisite. For second course also there should be one prerequisite. Okay, it's 1 2 3. 2 and 3 can have course 1 as a prerequisite. In this case, course 2 and course 3 are not prerequisites for any course. Still didn't get that. The university wants to estimate the efficiency of the allocation of prerequisites. Efficiency of the allocation of prerequisites of courses by maximizing the number of courses that are not prerequisites for any other course. For maximizing the number of courses that are not prerequisites for any other course. Find out what's the maximum such numbers of courses possible. It is guaranteed that A of I is always less than I, thus making sure that it is possible to allocate the prerequisites for each of the sub courses. Okay, other possible could be following. Course 2 has a course 1 as a pre. 3 has course 2 as a prerequisite. Thus, only course 3 is the only course that is not the prerequisite of any other course. This answer is 2. Okay, output should be the output of single line content indices correspond to the maximum number of possible courses which are not prerequisites for any other course. Okay, for this question we need not have a map, so let's just have an array. Okay, we'll have our arrays back after reading the array. We'll take if they are given some more sample test cases, it would have been helped. Okay, let's read the question one more time. There are n courses in a university being, we still have 18 more minutes, being offered. These courses are numbered from 1 to n in the increasing order of the difficulties. For each course, you can have some courses as prerequisites. The prerequisite courses for a course should be of lower difficulty than it. You are given an array A of size n. Okay, from 1 to n is the difficulties. Okay, at 1 is the least difficult, 2, 3. Okay, let's say those are like indexes but starting from 1. Array A of size n, where A of I denotes that there should be at least A of I prerequisite course for ith course. So for course 0, there are like 0 courses. For course 1, there should be 1 prerequisite. For course 2, it is 2 prerequisite, and the ranking is 1, 2, 3 difficulty ranking. Okay, the unit wants to estimate the efficiency of the allocation of prerequisites of courses by maximizing the number of courses that are not prerequisites for any other course. By maximizing the number of courses, we need to maximize the we need to find the maximum of courses that are not prerequisites for any other course. Okay, maximum number of courses that are not prerequisites for any other course. Find out what's the maximum such number of courses possible. When you find such number of courses possible, let's just say my thought is, let's take a loop and we'll say in that loop if we'll take an variable m. Okay, now if any number is greater than m, let's say that those are 0 prerequisites. If it is greater than m, then m will be equal to a of I. M will be equal to a of I. Okay, now what will this will give us? It will give us our maximum value in the whole course. So that course will be requiring 3 prerequisites, maximum number of prerequisites. To get the elements which does not require prerequisites, it will be just the total number of courses minus highest prerequisite number, that is n minus m. So you want to maximize the, I guess I cracked it. I guess it's done. Make sure it's possible to allocate the prerequisites of each of the course. Then I want to estimate the courses by maximizing the the number of courses that are prerequisites for any other course. Find out what's the maximum such number of courses possible which are not prerequisites. So like if if the most difficult element needs or moderately difficult course needs 3 or 4 prerequisites and there are like only 7 prerequisites, the chances that 2 courses are not a prerequisite of anything. So that's what we are doing here, and that semicolon is out of habit. We are having those many 2 unique courses. 8 out. Okay, yeah, why are we giving? I'm giving our answer as input. We got 2 and 1. Let's copy all this, let's paste this, and let's submit. We still have 10 more minutes, but I'm gonna end because it's 1:52 right now here and my brain is not in its best shape or best activity or best state, whatever it is. Finally, we even solved the second question of the day. I am really motivated to solve few of the questions, and that's why we have changed from learn it's not learn modules from those time complexity modules to this rate advice division, so that I felt for today I can do sums which are little difficult to me because I'm a 2-star right now. And thank you, that's it for the day. And as usual, you can find all these codes in my GitHub. Okay, don't tell me I have created files here itself. No problem, I'll move them into CP. And now let's go to CP and let's check our status. Yeah, we are having 2 files. We'll add them and we'll commit them saying day 7. Today's day 7, right? I guess so, day 7. And I need to push it, and I'll push it in the off screen because I need to enter my password. Thank you. That's it for today. Yeah, you need to save this.